6.1 on the law of sines. So as long as you have a triangle labeled ABC, you can label it anything you want, but ABC works for this formula. And then the sides opposite those angles are always used with lowercase letters ABC. So the law of sine works for any triangle. The trick that we've used in the past has always been for right triangles, but this proportion works for any triangle. As long as you have three parts of a triangle, angles and sides, whatever combination, you can use this proportion to solve for the other missing sides and angles of the triangle. You're just going to use two pieces of the proportion at one time. So A over sine A is equal to B over sine B, or A over sine A is equal to C over sine C, or combinations of B and C. It doesn't matter which two you use, you always just need two sets of information. These next three formulas will give you the area for any triangle. So in geometry you learned that the area of a triangle is 1/2 base times height. Well, we don't always have the base or the height of the triangle, we usually have sides and angles. So these three formulas are all the same thing. You need two sides of the triangle and the angle that is between those two sides. And you can use any one of these three. So let's look at our examples. Example 1, we are using the law of sines to solve the triangle. And remember, when you're solving a triangle, that means to find all sides and angles. So in this triangle, we were given angle A is 25 degrees, angle B is 35 degrees, and side A is 3.5. So the first thing I want to solve for is angle C. If you know two angles in a triangle, then you can find the third by subtracting those from 180 degrees. So we know angle A is 25, angle B 35. So if I add those two together and subtract from 180, we're going to get that angle C is 120 degrees. So now that I have all three angles, I'm going to start setting up my proportion to find the missing sides. You always have to start with a side and an angle that are opposite from each other, that you have both pieces of information. So if you notice, side A is 3.5 and angle A is 25. So I'm going to use those two to start using the law of sines. So I'm going to do 3.5 over the sine of 25, and I'm going to set that equal to the other part of the proportion, side B over the sine of angle B, which is 35. Okay, so to solve our proportion, we're going to cross multiply. So that's going to give me sine 35 times 3.5 equals B times sine 25. So my goal is to get little b by itself. So to do that, I'm going to divide by sine 25 on both sides. On the right-hand side, the sine 25s are going to cancel. So then B will be sine of 35 degrees times 3.5 divided by the sine of 25 degrees. Now, a couple of tips when you're typing this in your calculator. First thing, you need to make sure that you're in degree mode. Then, after you type the 35 degrees, you want to make sure to close parentheses, because when you do times 3.5, you don't want that to be included in the sign. So anytime you're doing an angle, make sure you close parentheses there. So if you type this in correctly, you should get that B is approximately 4.75. Okay, so now we're going to do the same thing to set up and solve for side C. So we're going to start the same way. 3.5 over the sine of 25 is equal to little c over the sine of 120. So same thing, we're going to cross multiply. So sine of 120 times 3.5 equals c times sine of 25. We're going to divide by the sine of 25 on both sides. So then in the calculator, we're going to type sine of 120 times 3.5 divided by the sine of 25. Make sure you close your parenthesis after your angle. So if you type this in correctly for little c, you should get 7.17. So in the end, make sure that you have three sides and three angles. And to kind of verify that you did it correctly, remember in geometry you learned that across from the smallest angle should always be the smallest side, and across from the biggest angle is always the biggest side. And then look at your side lengths to see that they're kind of close to each other. You're not going to have anything outrageous and crazy numbers in the hundreds if the rest of your numbers are, in the tens or less. Okay, so we solved the triangle once we have found all three angles and all three sides. Okay, on example 2, we're going to do the same thing. They just didn't give us a picture here. So we've been given that angle A is 55 degrees, angle B is 42 degrees, and side C is 3/4. So the only thing I can solve for first in this triangle is angle C. So if I add 55 and 42 together and then subtract from 180, you should get that angle C is equal to 83 degrees. Now I have enough information to be able to use the law of sines and set up my proportion. I have side C and angle C, and so that's what I'm going to use to start my proportion. So I'm going to do 3/4 over the sine of 83 is equal to little a over the sine of 55. So I'm going to cross multiply. So this time I'm going to do 3/4 times the sine of 55 and then divide by the sine of 83. So I'm just kind of skipping a step in this one and moving straight toward multiplying and dividing. So if I type this in your calculator, you should get that little a is approximately 0.62. Now we're going to do the same thing for little b. We start out the same way. 3/4 over sine 83 is equal to little b over sine 42. We're going to multiply across. So 3/4 times the sine of 42 divided by the sine of 83 will give me little b. And when you type this in for little b, you should get 0.51. And again, make sure that your numbers kind of match up. Angle C is the biggest angle, so side C is the biggest side. Angle B is the smallest angle, and side B is the smallest side. And our numbers are pretty similar to each other for sides. Okay, number 3, we're also going to solve the triangle, but this time they gave us two sides and one angle. So we have to start this problem differently. Since we have side A and angle A, that's where we want to start our proportion. So 11.4 over the sine of 58. The only thing I can put on the other side is side B is 12.8. So that has to go over the sine of angle B. So I'm going to be solving for the angle B first on this one. We're going to cross multiply. So this will give me 11.4 times the sine of B equals 12.8 times the sine of 58. Now our goal is to get B by itself. So we use kind of what we learned in chapter 5 on solving for angles. We're going to have to divide by 11.4 first, and those will cancel on the left. And then I have the sine B is equal to 12.8 times sine 58 over 11.4. So remember, to get angle B by itself, to get rid of the sine, we have to do the opposite operation of sine, which is sine inverse. So when I do sine inverse on the left, I have to do sine inverse on the right as well. So when you type this in your calculator, be very careful. You can do it all in one step, or you can take 2 steps. But make sure you're taking the sine inverse of the whole number, 12.8 times sine 58 divided by 11.4. And if you do that correctly, you should get that angle B is 72.2 degrees. Well, now that I have 2 angles in the triangle, I can solve for the third angle by adding the 2 and subtracting from 180. So 50 degrees plus 72.2 degrees subtracted from 180 gives me that angle C is 49.8 degrees. Well, now that I have angle C, I can set up the law of sines and solve for side C. So we're going to do 11.4 over sine 58 equals side C over the sine of 49.8. Cross multiply and divide. So 11.4 times the sine of 49.8 divided by the sine of 58. So if you type that in the calculator, you get that side C is approximately 10.3. So remember, the only reason that you're going to do sine inverse in your calculator is if you're solving for an angle. If you're solving for a side, you shouldn't have to do the inverse function. Okay, number 4 wants us to find the area of the triangle. And at the beginning of this lesson, I showed you 3 formulas to find the area for any triangle. You have to have 2 sides and the included angle. The angle they give us is B, and they say that it's 72 degrees and 30 minutes. Well, we've seen this notation a couple of times this year, and remember that it's 72 degrees plus 30 out of 60 minutes. So if you type that in your calculator, you'll get that this is 72.5 degrees. And then they gave us that side A is 105 and side C is 64. So we're just going to plug into the area formula, which is 1/2 of A times C, so that's 105 times 64, times the sine of 72.5. So I type this all in my calculator, and I get that the area is 3204.5. And since this is area, we're talking about units squared. Now, they didn't give me meters, inches, centimeters, or anything like that, so we're going to go ahead and put UN squared if we don't know the unit. Okay, so all you have to do here is plug it in the formula, find the area. They should give you everything that you need on this problem. Okay, last one, example 5 says that because of prevailing winds, a tree grew so that it was leaning 4 degrees from the vertical. At a point 35 meters from the tree, the angle of elevation to the top of the tree is 23 degrees. Find the height of the tree. So let's start by drawing a picture. So I need some grass. And it said that this tree was leaning 4 degrees from the vertical. Well, vertical means straight up and down or 90 degrees. So if it's 4 degrees from the vertical, that means I'm going to go in 4 degrees and draw my tree leaning. Well, if my tree is leaning in 4 degrees from 90 degrees, then that means the angle of my tree is 86 degrees. Okay, then it said that a distance of 35 meters from the tree, we have another angle. So I'm going to go out 35 meters, and then it said the angle of elevation to the top of the tree. So the angle of elevation is from the bottom to the top. So to the top of the tree is 23 degrees. So if I just finish out my triangle here, I need to know the angle up at the top of this triangle. So if I add 23 and 86 and subtract from 180, you'll get that this angle is 71 degrees. Now they want me to find the height of the tree, so I'll put an X over here. So we're going to use the law of sines. In order to use the law of sines, you have to have a side and an angle that are opposite from each other. So that's the 35 meters over 71 degrees. So 35 over sine 71, and we're going to set that equal to the x that I'm solving for over the sine of 23. So if I cross multiply, 35 times sine 23 divided by sine 71 will give me x, which is the height of the tree. So if you type that in correctly and make sure you close your parentheses around your angle, you get that x is 14.5. Well, I'm not going to box in x is approximately 14.5 because there wasn't an x in the problem. They asked to find the height of the tree. So you always want to reword your answer to a word problem and answer whatever is being asked. So I would write the height of the tree is approximately 14.5 meters. Okay, your homework for this section is the worksheet 6.1 that I handed out in class. Try to do half of it tonight, and then we'll finish the other half in class tomorrow.